on these problems, we're trying to find the nature of the solutions, not the actual solutions. So as I said in the earlier video, we would revisit this. This is what we're talking about, the discriminant. This is the piece right underneath the radical. If you end up with a positive under the radical, you get two real solutions. That could also be rational if it's perfect square. If it's negative, you get two complex solutions or two imaginary. I'm going to call them complex. Here I wrote imaginary. It basically means you have an imaginary number in your solution. And then if you have 0 under your radical, okay, you have one real solution, or what we'd call a double root. Okay. So in this case, we use the A, B, and C. We have to be equal to 0 first. And when B is 5, 4 times 2 times negative 7. So when I do that, 25 plus 56 is 81. If I get a perfect square, we get two rational solutions. If I do the same thing with the discriminant, A is 1, B is 4, C is 14, and I plug into B squared minus 4AC. 4 squared minus 4 times 1 times 14 is 16 minus 50. That equals negative 40. It does not matter if this is a perfect square or not. If it's negative, we're going to say two complex solutions. Here, my A is 1, my B is 10, my C is 25. 10 squared minus 4 times 1 times 25 is also 100. 100 minus 100 is 0. That's a double root. Okay, that means you basically have one solution. And finally, 2x squared minus 3x minus 11. A is 2, B is negative 3, C is negative 11. When I plug in, I get 99. Even if I could simplify that radical, which I can, if the number is greater than 0 but not a perfect square, we have two real roots. So our examples of these are right here. So when I do this, essentially, I first come up with my A, B, and C. My A is 2, my B is 11, and my C is 15. So this becomes 11 squared minus 4 times 2 times 15. 121 minus 120 equals 1. That's a perfect square, so it's two rational solutions. And that's my answer. I don't care what the actual answer is. I'm just looking for the nature of it. Here we get A equals 1, B equals negative 6, and C equals 20. So negative 6 squared minus 4 times 1 times 20. 36 minus 80, and that's negative 44. So that's two complex solutions. As I come down here, my A equals 3, my B equals 6, and my C is a negative 10. We have 6 squared minus 4 times 3 times a negative 10. That's 36 plus 120, which adds up to 156. 156 is not a perfect square, but it is greater than 0, so it's two real solutions. And finally, my A is 9, my B is negative 24, and my C is 16. Negative 24 squared minus 4 times 9 times 16. All right. Negative 24 squared is 576. And then 4 times 9 times 16 is 576. 4 times 9 times 16, 576. And this is 0, which means my answer is 1